So now we begin with the next chapter, the questions next chapter, which is motion in a plane, and the first topic in it, which is vectors. Now, see, we got close to 15 to 20 questions in this topic, vectors. Now, one thing that I would like to address here before we begin the session is that most of the students tend to replace each and every identity they have learned in scalar algebra, right, with that of vector algebra, and of course that will help you in saving a lot of time, and at times it also helps you in eliminating options because you can just make very good inferences out of scalar algebra and use them in vector algebra. But one of the most important differences between these two is that there are many identities which hold true in scalar algebra, which hold true in scalar algebra, and at the same time do not hold true in vector algebra. So these differences makes a huge impact while you solve the questions. Okay, so it should always be in your mind that preference should be given to vector algebra identities in such a way that you always tend to write down these identities based on the vector products itself, not by analyzing them using the algebra, which is the scalar algebra. Okay. Well, from which I mean that you can directly say that a plus b the whole square is a square plus b square plus 2ab. Yes, I do understand. But that way of writing will not hold true for every identity in algebra, in scalar algebra, when you try to use the same in vector algebra. Okay, so that's something that I really want you to understand, because JEE mains, for that matter, even NEET will not ask you questions which are based on very simple algebraic identities. Okay. Having said that, I also have to to acknowledge that some of the questions are easy. For instance, this is a very easy question, but these are not the ones which I say are directly based on algebraic identities. No, in the course of this series, we'll see there are 2 to 3 questions which you can just solve directly using scalar algebra, which is very lucky that because of the fact that those identities hold true for vector algebra as well. Not this case always. All right. Okay. Now, coming to this question here. So we've been given that vector A and vector B makes an angle cos inverse 5/9 with each other. And we've been given that vector A plus vector B is root 2 times vector A minus vector B. So the LHS is magnitude of vector A plus vector B. So first we'll consider this LHS alone. So what is vector A plus B dot vector A plus B? Gives us A dot A plus B plus B dot A plus B. A dot A plus B gives A dot A plus A dot B. B dot A plus B gives B dot A plus B dot B. Why? Why? Which identities? I've used 2 different identities here. Let me know if you have realized what identities. Let me know what comes to your mind when I say have used different identities here. Okay, which one? Now, this further gives us A dot A plus, oh, sorry. So I'll just bring in these 2 ones together. A dot B plus B dot A can be written as A dot B plus A dot B. Why? Because B dot A is equal to A dot B. Again, so let me just mark that for you. So there is one identity used here, another one used here, and I have made use of a third identity here. All right. So b dot a is equal to a dot b. So it can be replaced. And further, we can write, we can add a dot b plus a dot b as 2 times a dot b. This is not cross, 2 times a dot b. Okay. And therefore, vector a plus vector b dot vector a plus vector b becomes a dot a plus 2 times a dot b plus b dot b. Okay. Now, see, I assume that you have absolute zero exposure to vector and vector algebra. That's why I am trying to go this in as detailed way as possible. Okay. So if you know the solution, if you're here for the direct solution, okay, I have not written the solution directly, right? Okay, maybe I'll try to do another solution which gives you the answer directly from the next question onwards. Okay, so let's now discuss about these three terms in detail, which are a dot a 2 times a dot b, and b dot b. Okay, now we got three cases here. One, a dot a, b dot b, and a dot b. Okay, so what is a dot a? A dot a, by definition of vector algebra, is magnitude of vector a times magnitude of vector a times cos of alpha. What does alpha represent? Alpha represents the angle between vector a and vector a. So this arrow here represents vector a. This also represents vector a. What is magnitude of vector a? The magnitude of vector a would be this much, which is a. Magnitude of vector a is a. Alpha is 0. Why? Because the angle made between one vector and itself is 0, which is cos 0. Cos 0 is 1. Therefore, a into 1 becomes a square. And hence, a dot a is equal to a square. Similarly, b dot b is magnitude of b times cos beta. The angle between b, vector b, and itself is 0, and cos beta therefore is cos 0. Therefore, this we get b into 1, which is b square. Okay. Now, what would be a dot b? Would be magnitude of a times magnitude of b times cos theta. Theta is the angle between vector a and vector b, and therefore this remains a dot b is equal to ab cos theta. So a dot a can now be written as a square, b dot b can now be written as b square, and a dot b becomes 2 times a dot b becomes 2 times ab cos theta. As we have written this identity for vector a plus vector b dot vector a plus vector b, the similar one can be written for vector a minus vector b dot vector a minus vector b, which gives us a square minus 2ab cos theta plus b square. From the question, it is given to us that vector a plus vector b is root 2 times vector a minus vector b. Now, if I square this equation on both sides, this becomes magnitude of a plus b the whole square is, by definition, mod vector a plus vector b dot vector a plus vector b. Similarly, magnitude of vector a minus vector b the whole square is vector a minus vector b dot vector a minus vector b. The LHS is a square plus b square plus 2ab cos theta, and the RHS, this part is equal to a square plus b square minus 2ab cos theta. So 2 times a square is 2a square, 2b square, 2 into 4, 4ab cos theta, right? So if I transpose every term from the LHS, so 2a square minus a square is a square, 2b square minus b square is b square, and minus 4ab cos theta minus 2ab cos theta is minus 6ab cos theta. Okay? And it is also given in the question that modulus of A is equal to n times B, modulus of vector B. So what is modulus of A? It is A. What is modulus of B? It is B. Modulus of vector B is B. So A is equal to NB. Now what we'll do is we'll replace every term in this equation A with NB, A with NB, which gives us 0 is equal to nb square plus b square minus 6nb into b cos theta. This becomes n square b square plus b square minus 6n b into b is b square cos theta. I'll divide this complete equation by b square. What I get is n square plus 1, b square by b square is 1, minus 6n cos theta. It is given in the question that A and B makes an angle cos inverse 5 by 9, which means theta, which is the angle between vector A and vector B, is theta is equal to cos inverse 5 by 9, which implies cos of this theta would be equal to cos of cos inverse 5 by 9, and cos of cos inverse 5 by 9 is 5 by 9, which gives us cos theta is equal to 5 by 9. So we can replace cos theta by 5 by 9. Now what we have is 0 is equal to n square plus 1 minus 6n into 5 by 9. Or in other words, we have 0 is equal to n square plus 9 minus 30n. I'll divide this equation by 3, which gives us 3n square plus 3 minus 10n. Minus 10n can be written as minus 9n minus 1n. Why? 3 into 3 is, okay, now that becomes basic. JE means we don't need to go up to that far, right? So essentially we get two values here, 3n minus 1 is equal to 0 or n minus 3 is equal to 0. Therefore we get n is equal to 1 by 3 and n is equal to 3. Now, if you want, you can just go one step further here, which will be if comparing these two values, n is equal to 3 and n is equal to 1 by 3. So if you substitute n is equal to 3 in the same equation and n equal to 1 by 3, if from this equation, right, from this equation over here, we get 6n b square cos theta is equal to n square b square plus b square because a is equal to nb. And if I divide this complete equation by b square, what I get is 6n cos theta is equal to n square plus 1, or in other words, cos theta is equal to n square plus 1 by 6n. In this expression, if we substitute n is equal to 3, this becomes 3 square plus 1, which is 9 plus 1, 10, by 6 into 3, which is equal to 18. And therefore, we get cos theta is equal to 5 by 9 again, because 9 plus 1 is 10, 10 by 18, 5 by 9. And the same goes with n is equal to 1 by 3. So 1 by 3, the whole square plus 1 becomes 1 plus 9 by 9, which is 10 by 9 into 3 by 6, giving us 5 by 9 again. So in both these values, n is equal to 3 and n is equal to 1 by 3, the expression holds true. But since the question very specifically says the integer value of n, we submit the answer as n is equal to 3 and not n is equal to 1 by 3. Okay? So yes, that's what to say about this question. Very simple one. The reason why I got the explanation to you in this depth is to make sure that you understand these algebraic identities and how do we expand A dot A dot B, B dot B, and what are the different identities that we use for doing problems based on vector algebra, and the difference between those identities and the one used in scalar algebra. All right, so moving on to the next question now.